audible?
Yes, you are.
Okay, sir. Thank you.
Yes, audible.
Okay, sir. A warm welcome and a very good evening to all dear participants. Resource person of today's section, Dr. Atul Juneja sir, and a chairperson of today's session, Dr. R.J. Yadav sir, and all the organizers of this program. Today we are having our lecture on descriptive statistics, presentation of data. Now I would like to introduce today's resource person, guest speaker of session, Dr. Atul Juneja sir. Sir is a former scientist and coordinator of Clinical Trial Registry India, CTRI, ICMR, National Institute of Medical Statistics, New Delhi. Sir is currently working as a guest faculty at AU Tibia College, Government of NCT, Delhi for research methodology and visiting consultant of biostatistics at PSRI Hospital, New Delhi. Sir is also visiting faculty in Nehru Homeopathic College and Hospital, New Delhi. Sir is presently member of various scientific committee like the member of National Advisor Board for Journal of Case Reports published by All Indian Institutes of Ayurveda. Sir is a member of DNB committee of Jaipur Golden Hospital, PSRI Hospital, Mata Chanan Devi Hospital, New Delhi, National Heart Institute, New Delhi. Sir is also a member of DSMB of Central Council for Research in Ayurveda, CCRAS, New Delhi, and a member of paper setting group for the examination branch of PGI, Chandigarh. Before that, Sir is nominated as a representative of ICMR for expert committee member of Central Population Control Board to provide the technical opinion to honor of National Green Tribunal on remediation of mercury as a result of mercury pollution in soil near thermometer factory Kodaikanal. The recommendations were expected by honor code. Sir is also nominated by the director of NIMS as member of MSAD of Bureau of Indian Standards. Sir had been a member of DNB committee of DL Kapoor Memorial Hospital, New Delhi. Sir also nominated for the paper setting panel for Central Council for Research in Homeopathy for the selection for the post of statistical assistant. Sir chaired the selection committee for the post of SRF in statistics at Central Council for Research in Homeopathy. And Sir had been a member of selection committee of various projects post as National Institute of Medical Statistics. Sir had been visiting faculty to Guru Gobind Singh IP University, New Delhi for teaching research ethics for PhD program. Sir has delivered more than 60 lectures on served as a panelist for the various capability building programs conducted by ICMR, DHR, NIP, CCD, Central Statistics Organization, RML, Hospital, PGI Chandigarh, Government Medical College Chandigarh, Rajasthan University of Health Sciences, Jaipur, Jaipur University, MD University, Rohtak, CCRAS, CCRH, Jamia Hamdard University, New Delhi during last 10 years. Sir is a member of National Academy of Medical Sciences and life member of Indian Society for Medical Statistics and also a life member of Indian Society for Information Theory and Application. Sir had been an annual member of Indian Association for Cancer Research. Sir had been published more than 60 publications to credit with 25 as first author and attended more than 70 national and international conferences, including invited talks. International participation include countries like USA, Canada, Singapore, China, and Malaysia. Now I would like to invite Sir for his today's session. Please, Sir.
Good evening, everyone. At the outset, let me take the privilege of acknowledging the organizers for this very important workshop which they are conducting, and it's really commendable that they have tried to reach out to, that's I understand is Institute of Applied Statistics, which is trying to reach out to throughout the country for disseminating the issues in research methodology and basic biostatistics, and which to the Ayush system as well as modern system. That's really commendable, and all congratulations to them. And I also, I'm privileged to be a part of this program, particularly when my senior Dr. Yadav was chairing the session. It's really an honor. It has always been an honor to be working with him, and thank you, sir, for getting me the honor. The topic which has been assigned to me is the presentation of data. I know many of you might be knowing about it and must have seen in various programs. But as the objective goes of this workshop, they start from the scratch and go up to the very reasonably advanced level of statistics, which is quite important. So there's always a link. So many of you might have felt that this is the basic thing, but always there is a connect is needed. So, and always one tries to remind ourselves that these things are important when we design our protocol, when we do our analysis. So this is ultimately what I would like to also acknowledge, make a point that the last time when I was sharing a session, it was a presentation on the conclusion writing. So the conclusion writing is just a one paragraph, but Dr. Ori was called to deliver that lecture. So I appreciate that you have taken all the micro level details of the research methodology and incorporated in this long program. Thank you so much. And thanks for the introduction. Organizer, how do I move on to the next slide? I'm not able to move the, okay.
Yes, sir. Use arrow key or mouse
Actually,
click.
that's the same way, no? Maybe the system is slow.
Yes, sir. Yes, sir. Definitely, sir.
So there are certain basic considerations for data presentation. You have got a raw data, and then you have you're at the stage, you have collected a data. Now you're stage of a compiling. So compilation starts with the data presentation, basic data presentation, and let's see what are the considerations for that. The most important thing for the data presentation is that it should be presented in a simple way, and then it should create interest in the subject for the reader. That's quite important. When we see, when you read the newspapers or any magazines, we look at the some graphics over there. If we feel interested, and then we start reading the article. That's what it happens. So it's important that our presentation should be such that it creates an interest for the reader, and should be concise without compromising on contents, facilitates further analysis, should be in line with the objective so as to understand the solution. It's not moving with the arrow key.
Sir, click on the presentation and then use arrow key. Firstly, click on the presentation and then use arrow key.
Okay, fine.
Okay. Thank you, sir.
Okay. Thanks a lot. So presentation of data is basically tabular as well as visual. So always one comes to our mind that when we're talking about the presentation, we always think about the graphs and all. Let's be clear that tabular presentation is also an important way of presenting a data in addition to visual presentations. So tabular presentation means that's a table. A table is a representation of a data or information in rows and columns. That's very simple. A table can be simple or multidimensional. Two by two table, 2 by 3 tables. That means the 3 levels of variables if we are include. So it goes accordingly. Text is the main content of the table. So always remember that what is written in the table is important rather than how it is made. Table is used to keep a track of information such as quantities, numbers, names, addresses, and other details, more focused on specific items with clear magnitude. So in case of visual presentation, a chart is a graphical representation of data and symbols like bars, lines, and slides. While there are different types of charts, the most common are pie charts, bar charts, and line charts. Charts contain minimal text. So there's a major difference between tabular and visual. Charts contain minimum text but gives an idea of the magnitude, whereas the table gives the exact idea of the magnitude. A chart is used to help understand a large amount of data and its component. So this is how the table looks like. Significance of tabulation: simplifies the complex data, facilitates comparisons, gives identity to the data. That's very important. What you have collected a data was in a raw form. Now, when you make a table of it, then it gives an identity, what we're talking about. So presents the evidence to the narrative impression. The Data once arranged in suitable form gives the condition of situation at a glance or gives a bird's eye view. This is what you have collected. Of course, the advanced analysis, the statistical analysis come later. But initial stage, you should know what you're looking at and what you're supposed to do in future. Approaches for tabulation. That's certain basic things the youngsters must always keep in mind, which normally, I mean, in spite of knowing ourselves, we miss on that. First of all, assign the table number. Never miss that. Give a brief title to the table. Title of rows and columns should be precise and linked with the title. For group data, the class interval should be with optimum width. Define the subject in practical terms. Unit of measurement should not be missed. Cannot be taken as obvious. Suppose we're talking about weight. So we know that weight we are taking as in kilogram, but we need to mention that. Height in meters or whatever, centimeter, whatever, it has to be clearly mentioned. Data should be arranged in logical considerations. Titles of rows and columns should be self-explanatory and not supported by footnote. That's very important. Footnote should contain the information which is not there in the table, but essential to understand the table. For example, that's very common that, I mean, you have given some p-values. So, I mean, you want to say that whether that's a significant or not, then suppose you have written a 0.001. So somewhere you have to, I mean, you can mention in the footnote that these variables were significant. So that in a way, we are trying to add additional information to the table, not to the existing one already there. And of course, if used from other source, do mention the source. That's very important. So types of tables, single dimensional, multi-dimensionals. You all know it. There's nothing to. So this is how it looks like. So graphs and diagrams. So now we're coming on to visual. So there's when always we take this as a synonymous, but to be very specific, that there's a difference between graphs and diagrams. Graphs express the relationship between the two variables. For instance, just to give an example, histogram line graphs are line charts are graphs, but bar chart is not a graph because it only gives a one variable. There are different categories, and but it is being used interchangeably. But let's be very specific about it. Graphs are representations to the scale. Diagram may or may not be. The graphs may facilitate computations such as median mode. Like less than a y, more than a y helps to calculate the median. So these are the advantages or the specific features of the graph. May not be very attractive. Let's be very clear. The graph might add to some more information, but may not be attractive. But diagrams most of the time are attractive. Rules for drawing graphs and charts. Proper selection of graphs and charts. Give the title to the presentation. Always remember that you give the title to the presentation. Selection of the scale should be in line with the magnitude of the attribute being presented, neither too small nor too big, and labeled like number of persons per 100, 1,000 or 100,000, etc., depending on the standard way of presenting a data. Should be neat, attractive with the proper shading and legends. Should be simple enough for an even non-technical reader. So let's look at the few different diagrammatic presentations. The basic one is line graphs. Line graph or the linear graph is used, also known as the line chart or a line plot, is commonly drawn to show information that changes over time. Helps to study the trends. Bar graphs. Bar graph is used to display the category of data and compares the data using solid bars to represent the quantities. X-axis defines the category and not the quantity. Whereas there's a slight difference with the histogram. The graph that uses bars to represent the frequency of numerical data that are organized into intervals. Since all the intervals are equal and continuous, all bars have the same width. So if there are intervals are different, then the width of the bar would be different. So that has to be, this is a basic difference between bar and histogram. And line plot. It shows the frequency of data on a given number line. X is placed above the number line each time when data occurs again. So it is not joined, but just the points are given. Circle graph. Circle graph is basically a pie chart, which all of us know that if something has to be represented from 100%, suppose there's a distribution, age-wise distribution. So if you wish to Suppose if you wish to divide the data in the, suppose the people in the 0 to 30 age group and 30 to 70 and 70 and above. So this makes the whole data complete 100%. So accordingly, the pie charts are made. That means the angle is calculated depending on the magnitude of that value. So another important one is which we always have read, must have read it in the college level or the school level. That's a stem and leaf plot. I mean, let me tell you, this is not very popular, but in fact, the initial graph structure which the students are taught. And box and whisker plot. Let's see how it looks like. This is how the line graph looks like. That means the Monday, the sales in the different days, Monday, Tuesday, Wednesday, you can always see that how the trend is moving. So this mainly helps to get the trend. Then bar charts. These are simple bars and there are multiple bars. So when there is a comparison between the two groups, then group bar charts are used, otherwise single. Stack bar. You know what is stack bar? Suppose there are stack bars or a column chart. They look like series of columns of bars. They are stacked on one on each other. Suppose we're talking about male and female proportions in different countries or different groups. So instead of making two bars or more than one as the need may be, they are stacked over one over the other. So the area at the bottom is minimized. So depending on the requirement, we choose whether we have to go for the multiple bars or the stack bars, right? So this is a basic comparison of a bar chart. In the bar graph, the on the x-axis, these are the categories. In the histogram, these are the continuous values actually, like 60 to 65, 65 to 70, and what is the frequency distribution during these years. This is how the pie chart looks like. That the whole data has been divided into 100%, and each slice is cut based upon its area. It's a simple calculation. That whole chart is 360. If it carries 50%, so 360 divided by 2 makes it 180. So accordingly, you can calculate the different arcs of that. So this is a stem and leaf plot. You know how it looks like. Just to remind you, because it's not very popular, and you'll all agree that we are not using it in routine way. Suppose if something is in hundreds and thousands, that helps. Suppose some data is suppose 078. So 78 is that means how many numbers are there in the unit place. So unit place are the numbers which are in the unit place are mentioned as leaves, and above that are mentioned as stem, like 15. So where 15 comes in the in stem, it is 1. That means at 100th place it is 1. And how many were there? So it gives a basic idea about of the strength, I mean, of the magnitude of the data in a different way, that it is in thousands or it's in 100. That it's for as just let me repeat, 078 means the two numbers 7 8, there were two numbers which were in the unit stage, uh, like 3 3 5 7 and 1. This shows that these four values had moved on to 10th place. 2 means they moved on to 100th place. 3 means they move on to 1000th place. So it's like that. So one is box and whisker plot. Box and whisker plot basically gives a summary. It presents the whole summary of the data. The process of abstract a set of data that is estimated using an interval scale is called box and whisker plot. It is also called just a box plot. You know what it gives? It gives the median. It gives the lower quartile. This perhaps we'll more talk about tomorrow in the when we go for the measures of central tendency, and maximum value and minimum value. So this gives a snapshot of the summary of the data. So you come to know how your values are distributed. And 25 lower quartile means the area which shows the 25% of the data. And upper quartile means that's a Q3, which gives the 75%. So we come to know how our data distribution is there. And basic summary, we come to know about it. And what is the minimum and maximum value. So we are in a position to, I mean, judge about any outliers. So frequency polygon is a line graph of class frequency plotted against class midpoint. So there are different histograms. You make the midpoints and join them. So the graph which comes is known as frequency polygon. So this again gives an idea about the frequency distribution. Ogive. Ogive is a cumulative frequency curve. So instead of individual frequencies, you keep on adding the curves and you see how the change is. Let's look at it. So one is less than ogive and one is more than ogive. So when one is moving in the upward direction and one is moving in the lower direction. So less than ogive moves in the upper direction, more than ogive moves in the lower direction, because the total frequency is added in the end in the less than ogive, whereas the in more than ogive it goes from maximum frequency to downward side. And the most important use of this presentation is that we are able to calculate the intersection value of more than ogive and less than ogive help us to calculate the median. So then another important presentation of data which is commonly used is the scatter plot. Scatter plots are the graphs that present the relationship between the two variables in a data set. It represents the data point on two-dimensional plane. It helps to assess the, always remember, linear association between the two variables, which is finally, when you compute, is the correlation coefficient. So always remember that. I mean, you are able to judge about the linear association. So this is how it looks like. So strong positive correlation, that means that the line is up in the upward direction, moving in increasing way, and the points are on the line. And if somewhere there is a scatter, that means the correlation is positive, but it's weak. If most of the points are concentrated on the line, so we say that's a strong correlation. Of course, the calculation, as I mentioned, that calculation part comes later, but this gives an idea. There is a strong relationship between the two variables. And then there's a strong negative correlation when the slope comes downward, and that means one value is increasing, another value is decreasing. So there's a strong when the points are clustered around a line. When they are scattered but move in the same direction, then there's a weak negative correlation. When the points are scattered over a whole graph and there is no trend which we can observe, then we always say that we don't find any relationship between the two variables. So there's another small concept which I would like to add. There's a further, you all might be knowing that the meta-analysis, which is now a very popular way of analyzing the data, since we have made various studies around and we wish to generalize what actually these studies try to say finally. So there are basic things which these analysis help us to look at through a visual presentation. One is forest plot. Forest plot is basically, let's look at it, just see how the values are plotted. The box between says about the magnitude of the risk. Like it is there are different studies and they're trying to study the relative risk. So some data show the positive risk and risk factor, or some show the protective factor, and the line between them is the confidence interval. And finally, the last point, which is with a diamond, gets the overall computation of the combined value. That is the basic purpose of this thing. And I'll not go into that. That the size of diamond depends on the type of variation in the data. Maybe that's maybe a different concept. That's like a random variation or a fixed model and random effect model that decides what the size of the. So this is how it, and it forms a very important part. Before commenting on anything, we first of all look at this and then start analyzing, start commenting on the data actually. So let me just read it again. Each horizontal line on the forest plot represents an individual study with the result plotted as a box and 95% confidence interval. It could be 99, but conventionally it is 95. On the results display as the line. The implication of each study falling on one side of vertical line or the other depends on the statistics being used. If individual study crosses the vertical line, it means the null value lies within the 95% confidence interval. This is a basic concept. This implies that the study result is in fact the null value, and therefore the study did not observe a statistical significant difference. This is just an explanation of confidence interval. The diamond at the bottom of the forest shows the result when all the individual studies are combined together and averaged. The horizontal points on the diamond are the limits of 95% confidence interval and are subject to same interpretation as any one other individual studies on the size of the diamond depends on the random to fixed effect ratio. This is a somewhat a different concept and can be taken by a concerned speaker when the situation arises, right? So there is another one is funnel plot. This is another important concept. The funnel plot helps us to study if this helps us to observe the studies which we have incorporated in our meta-analysis, if there are any publication bias or not. This basically shows the spread of the data. That means we have included all studies which are having low effect size or high effect size relating with the precision. That means we are trying to plot the standard error versus the effect size. So if this falls somewhere like it, that means that they're evenly spread. So this is an important point of in judging whether studies which we have included have incorporated all the studies which are there. We have not picked up on the ones which are only positives or negatives, right? So interpreting funnel plot, already mentioned, but just I'll read it for you. The funnel plot is a method to assess the potential role of publication bias. It assumes small studies are more likely to be susceptible to publication bias than large ones. This is what the hypothesized if is there. The funnel plot is a graphical representation of size of trials plotted against the effect size, they report. As the size of trials trials are likely to converge around the true underlying effect size. That means if the size is more, I mean, you can more, the confidence interval would be very small. That means standard error would be less. So you more rely on that. One would expect to see an even scattering of trials either side of the true underlying effect. When publication bias has occurred, one expects asymmetry in the scatter of the small studies, with more studies showing positive results. That's what I've mentioned, that those showing the negative result, right? So that's all I have for you today. Thank you so much for getting me this honor.
Thank you, sir. Thank you so much for your very
Over to
knowledgeable
organizers.
and interactive session. I hope that participants get benefited for today's session.
Thank you so much, ma'am.
Now, I request participants that please raise your hand and write your query in chat box.
If there is any query regarding today's session, then please raise your hand or write your query in the chat box. Later, if there is any query remaining, then I have left a mail ID in the chat box. You may mail us your query with the name of our respected guest speaker in the subject line. So I can forward that query to the our speaker.
Now, I would like to introduce today's chairperson, Dr. R.J. Yadav sir. Dr. R.J. Yadav sir is currently working as a senior consultant at National Institute of Biological, Ministry of Health and Family Welfare, Government of India. Before that, sir served in National Institute of Medical Statistics, NIMS-ICMR as Director Grade Scientist G. Sir is having 31 years of research experience and 21 years of administrative experience in ICMR, New Delhi. Sir is having the experience of evaluation of 30 studies for CARE, WHO, UNICEF, USAID, Deputy of WCD, Government of India. Sir has published 98 research papers in various international and national journals and also published 90 scientific reports. Dr. R.J. Yadav sir has received various awards such as Professor P.V. Suketam Award 1999, WHO Fellowship by Government of India 1998 and 2005, and Fellow of Indian Society of Medical Statistics in 2007. Sir has been member of various scientific like General Secretary of ICMS for 2011 to 2013, and currently life member of 6 international and 10 national scientific societies. Sir is also a member of SASC for NIN, a member of IRB for NIPCCD, and NIHEW in Ministry of Health and Family Welfare. Now I would like to request Dr. RJ Yadav sir to kindly share her views and sum up today's session. Sir, please.
Hello.
Yes, sir.
Yes, sir. Welcome, sir.
Okay. So I would congratulate Dr. Juneja for excellent presentation. It was a very well-designed lecture on statistics for the researcher, medical professional, which will be very useful in preparing their manuscripts in formulation of and their research projects for their publication of research papers. Lastly, thanks to the organizer, especially Dr. Subham Pandey and his team. Thanks to everyone. Good evening.
Thank you so much, sir.
Thank you, sir. And now, on behalf of the Institute of Applied Statistics, we convey our sincere thanks to all participants for their active participation during the session. We heartily thanks today's resource person, Dr. Atul Juneja sir, for a very interactive session, and also thanks to Dr. RJ Yadav sir for chairing today's session. Now, this is the end of today's session.
Thank you. Bye.